Hi, this is Chad. I'm here with Kevin, and Kevin is manually assembling one of E3's 3-digit numerical display boards. So Kevin, tell us a little bit about this part of the process.
Yeah, so we're going to go through stenciling and actually do a reflow with a system that we built using the E3 embedded products. We're not going to go into a lot of detail on stenciling because SparkFun has an excellent video on that, and for those of you not familiar with it, I would suggest you go to the SparkFun website and do a search on solder stenciling to take a look at how they do it. But basically we've laid our board in place, we've locked it in with the frame, we have our lead-based solder put on our spreader, so we're going to go ahead and apply a coat. And then we're going to go back and clean off the excess. Lead-free solder is not generally recommended for these processes unless you have an extremely good oven. The reflow temps on lead-free is quite a bit higher, and there's a good chance you will damage your boards if you try to do lead-free with the toaster oven. Now that the solder has been applied, we'll pull the stencil all the way and we're ready to place our parts.
We have finished assembling our 3-digit numerical display board, and now it's time to cook it. So what you're looking at here is essentially a Black & Decker toaster oven where Kevin ripped the guts out of it and put our own products in. So essentially this is current E3 products helping us design, build, and test future E3 products. So Kevin, tell us what we're looking at here.
Yeah, so we're going to go ahead and drop the board in, and if you'll notice there's 2 screws that I dropped in the board that we're going to reflow. The wire rack is fairly large. We want a wire rack so that we get good air circulation, but we also want something to make sure the board doesn't vibrate off the rack if there's any vibrations in the oven. So we'll go ahead and set it in the center of the oven and we'll get ready to do a reflow. The board to the left is our reference board, and it has a thermocouple attached to the top and the bottom. The air temperature is not what we're interested in. We're interested in the board temperature. So we use this as a donor board to mimic the temperature that we're going to see on the actual board that we're reflowing. To the right we have our control panel. We can do reflow, cool down, a preheat mode, which is useful for drying out moisture sensitive parts, and then our system reset. The 2 displays show the top and bottom temperatures that we're reading off the thermocouple, and then to the far right we have our control system with our thermocouple inputs, our low voltage DC running in. We also have a serial port that we're pulling out so that we can record the data if we'd like to go back and look at our temperature profiles. On the top we have a fan. We do active cooling. You want to be in the liquidous area, which is above 183 degrees C for lead-based solder. You want to be in there about 90 seconds or so. Too short and you won't get good solder joints, too long and you can actually burn the board. So the active cooling helps to keep us within the time frames that we're shooting for. So now we'll go ahead and slide the door closed. We'll hit the go button, and we're showing that we're doing a reflow, so we'll just sit and wait.
Okay, we're almost at our peak temperature on this reflow. We should get an audible indicator. There it is. This is letting Kevin know that it's reached its peak temperature and it's time to start the cycle downtime. Alright, we got a solid signal. Kevin pressed the cycle down function, essentially. And as you can see here, our fan is kicked on and it's pulling air out of the reflow oven at a specified rate. And hopefully you can read our 3-digit numerical display and see that the temperature is in fact falling. As you can see, the fan's still turning. Alright, there's an audible notification. And there's the latest E3 3-digit numerical display.
For more information about the processor-independent embedded platform, go to our website, e3embedded.com.